Hello, welcome to the first video for um, Math 2110 Principles of Statistics. We're going to get started now. I don't have the textbook yet. I will get that on Monday morning. So I'm going to be basing these first few videos solely on the slides published by the textbook provider, who is also um, who does your Hawks Learning, also provides the homework and test environment that we're using. Um, so I'm a little less prepared than I normally would like to be, but I think we're going to be okay. I'm also having some technology difficulties this evening. The PowerPoint doesn't want to open the PowerPoint file, so I've got them open in LibreOffice. And for some reason, when I do the slideshow, it shows a blank slide instead of showing the text that's supposed to be there. All right, so we are going to get started. We're going to start with some basic vocabulary of statistics. Um, and some of these are fairly important concepts. We will go over the syllabus and all of that stuff in person on Monday and Wednesday, so I'm not going to spend time on that right now. Okay. So, the goal of statistics is to basically tell you what numbers mean in relation, what numbers and claims about things mean in relation to other claims. So, is how different is 75% of a group from 76% of a different group? Is that a big difference that matters? Um, is it important that you know that say 30? Well, it's probably high. To invent semi-plausible numbers, let's say what does it mean that 30% of the people in a survey think that the president is doing a good job or a bad job or whatever. So we see statistics a lot, especially in the news. If you read scientific papers, you see statistics a lot. If you're planning on going into industry in some places, some places use statistical process control to tell them how important a change is that they're seeing in the process. Um, Statistics come into play when you're trying to decide whether a part is good or not, and how much error they can allow, whether the process is trending towards producing more error or less error. All of that comes into statistics. Um, and I know statistics have a terrible reputation. They've had one for years, going back to when Mark Twain said there were three types of lies, damn lies, and statistics. Um, More recently, you see things like 70% of all statistics are made up on the spot. That's frequently attributed to Abraham Lincoln, and as he said on his webpage, something like that. So that's clearly meant to be sarcastic. But so our goal in this class is to help you learn how to interpret statistics and understand what they mean, and to do some statistical calculations on your own. So let's start with some vocabulary. Statistics is the science of gathering, describing, and analyzing data. Um, it is one way to use the word. Another definition is that it's the actual numerical descriptions of sample data. Um, so some other key concepts is a population. Population is the entire group that you might be interested in. So an example of a population might be all of the students in Washington State Community College. Another population larger population could be all of the community college students in Ohio or in the U.S. or in the Northwest Territory region or whatever. So a population would be everybody within that one group. A variable is a value that changes among members of the population. So, you know, eye color could be an example of variable. Incoming SAT scores could be a variable. GPA could be a variable. Um, all sorts of things could be variables. That it's in anything that could be different between members of the population. Data, of course, is the counts or observations or anything about variables. So the actual values of the GRE score, or sorry, not GRE, of the SAT, the actual value, the recorded eye color, observed eye color. That's all data. Census is a study where you obtain data about every member of the population. We're in a census year right now. They're trying to obtain data about the entire population of the United States. Parameter is a numerical description of a population characteristic. So this would be that SAT score, but not the eye color, right? So it's a numerical description. A sample is a subset of a population from which data are collected. So if our population is all the students in Washington State College, a sample would be the 200 that we talked to. Sample statistics then are numerical descriptions of the characteristics of that sample. Right? So it's very important that you keep in mind that you've got a big group that's the population, and this little group here is the sample. Do I have a highlighter thing? If I had this running the slideshow, I would have a highlighter I could use to make sure I pointed this out. But I do want you to take note of that figure there and keep that in your mind when you're talking about a population and a sample. So again, population is the whole group, sample is the part of the group, population is the group we want to know about. We want to know what the population thinks about something, how they performed on something. We want to know something about them. Sample is the group that we can know about. It's it's usually not practical to do a census and get things from the entire population, so we deal with sample, and so that's the group that we know things about. Characteristics of the population are parameters. Characteristics of the sample are statistics. Generally don't know what parameters are. They generally are fixed. They don't change. Statistics, we know what the statistics are. We've taken the measurements. We've seen we've observed things. We've recorded all the numbers, and so we know what the statistics are. But if we went back and changed the sample, looked at a different sample in the same population, our statistics would change. All right. So one of the things I like about these slides that came is they come with a lot of example activities. So I'd like to, after we look at the beginning, go ahead and pause, take a minute, and do the exercise. Figure out which is the population and which is the sample. Okay? So if we've got a survey, we have 359 college students at a university were asked if they'd tried the flavor of the month at a coffee shop. 83 students that were asked said yes. So I want you to think about, in this situation, what is the population that they're trying to get information about, and what is the sample? Okay, the second one, same question, what's the population, what's the sample? So they surveyed 11,025 households and found that 24% subscribed to satellite radio. So what is the population? What is the sample? Okay, go ahead and pause. Think about that. Look at these. Write it down. We'll go on. All right. Okay, did not spend enough time looking at these. I thought the next one had the answer. Okay, so the population in part A here is the all college students at the University of Jackson. The sample is the 359 that they actually talked to. And the second part, the population would be all the households in the United States, and the sample would be the 1,125 that they talked to. I don't have the text for example 1.2, so we are going to not do that one. Okay. So we've also got two broad branches of statistics. There's descriptive statistics, which basically you're trying to come up with a way to summarize the data. So usually this is something like reporting the average and some another number that gives you an idea of how much variation there is within that group. So it's telling you what the data looks like. The other main branch is inferential statistics, and so that's using descriptive statistics to try to make an estimate of what the population means. So descriptive statistics are focused on the sample. Inferential statistics are taking that sample and trying to estimate what it would mean for the larger group. So if we look back at our example here, we've got our descriptive statistics that 24% subscribe to satellite radio. Inferential statistics would be trying to take that 24% and use that to estimate what the total number of households in the U.S. That subscribe to satellite radio are. Okay, so let's do this example. If we're looking at a news report, what are the inferential and descriptive statistics from this excerpt? Okay, we've got AOL had 900 journalists, 500 of them at its local operation. By the end of 2011, Bloomberg expects to have 150 journalists and analysts for its new Washington operation. With some, text missing in the end here. So again, descriptive statistics talk about our sample that we know. Inferential statistics talk about things that we're inferring based on a sample. All right, go ahead and take a minute, figure that out, and we can move on. So when we talk about that AOL had 500 journalists at its local news patch, or had 900 journalists, 500 at a certain site, they're describing the actual counts. They're things that we know, so they're descriptive statistics. The other one, keyword to see there is it expects to have 150 journalists, so they're making an estimate, probably based on some past statistics that were cut out of the excerpts, so we don't see. So that's an estimate, so it's an inferential statistic. Okay? All right. I'm going to stop this video here and queue up the next set of slides and do another one. I'm going to try to keep these brief so you can so they're easier to work in, and so you can take a break in between things, and I can take a break in between things, and yeah.